Sometimes we have hard time finding the components along the x and y and z axes of a coordinate frame for a vector, in this case of a load F equals 600 newtons. And especially this is the case if we didn't have too much exposure or practice with projections on various planes before. But the matter is very simple and can be related to what happens in a right triangle. For example, imagine that this is the x-axis, as we will put it most of the time as a horizontal one, and this is the y-axis right here. And in this triangle, if this would be a vector, if this hypotenuse of the triangle would be a vector, then knowing the angle with one of the axes, in this case the x-axis, we can figure out both the components x and y. So how do we do that? Well, the cosine, the trig function sine and cosine have to do with this. So, for example, sine of theta, it's going to be by definition of the sine is the opposite leg divided by the hypotenuse. And the cosine is the adjacent leg right here divided by the hypotenuse. For the tangent will be we eliminate the hypotenuse and we have opposite leg divided by the adjacent leg. So, let's apply these functions to figure out the components. We can see that the opposite leg will be basically the fy component, and the adjacent leg will be the x component. So in this case, for this vector f, we can see that we have an angle that it's the 60, it makes a 60 degrees angle with the plane that is parallel to the xy plane. In this case, this is a line that is parallel to the x-axis, and this is another line that is parallel with the y-axis. So this plane that is right here, it's a plane that is parallel to xy plane. The component in this plane, if we take the projection of that vector on that plane, we have it as this is the one, for example, in that plane. We can see that basically that component is to the adjacent leg to the sine to this 60 degrees angle. So that's why we can write it like this way. That component right here in the plane, it's going to be equal with f cosine 60. Now, there is another leg which is opposite to the angle, and we see that this leg is parallel to the z-axis, this one right here. So in that case, this magenta leg, it's going to be the opposite, to the angle. So we use that sine function that we just defined previously. So we have f sine 60. So we quickly figure out the z component of that vector. Now, in order to find the x and y component, we have to work with this component in fxy plane to decompose it. So we need another angle, and in this case, it's a 30-degree angle that it's done with this axis, that is, this line that is parallel to y-axis. So this is, we can see that this component, y component, it's the adjacent leg to the angle of 30 degrees. So that in that case we use the cosine rule. In this case, we can see that fy is going to be fxy times cosine of 30 degrees. And then if we plug this one right there, then we have f cosine 60 times cosine 30. Now if we want to figure out the other leg, which is basically parallel to the x-axis, in this case, it's the opposite to the angle, the 30 degrees, and that is basically, we can see it fxy sine of 30, and then this, if we plug it again, we get f cosine 60, which is right there, times that sine, and I made a typo here, is supposed to be 30 degrees. I'll need to correct that. And that is, as we can see, very simple way we can figure it out. Components along the axis by using the sine and cosine if we know the angles. There is another problem. Sometimes we might not know the angles, and we have to use what is called the Pythagorean triples. So this is in the next video.